And then let me start sharing my screen. And first of all, I need to apologize. That was the first quiz that I had written in Blackboard, and there were many more problems with that for between the two sections, people taking it, than in my math lab quiz. There were several people who uh, sent me emails that they could not see the diagram. There were people who didn't realize they had submitted it and they hadn't. So that happened to me like that. And looking at the way that Blackboard graded, it took off if the right answer was there, but in the wrong order. And so if it's all right with you folks, I'm thinking of making it.
Is it me? I'm losing my sound.
Okay,
Yeah, I'm not getting any sound.
we'll switch. Does this sound any better?
Much.
Okay, then I'll use the headphones today. We're actually Spectrum to guy come and look at our internet today, so I apologize for that. So anyways, it seemed like there were a lot of problems with the Blackboard quiz, more than with the My Math Lab quiz. So if it's all right with you folks, I'm going to make an executive decision and say that tests and quizzes will be my lab's questions as opposed to handwritten Blackboard questions. Another executive decision that I'd like to make, but it's a change in what's on the syllabus, so I want to run it by you folks first, is, and let me stop sharing so I can see everybody as I discuss this, I had initially said that tests would be given during class time, but as I'm looking at this gallery view that I have, I can't see you guys. And even as I look at what was supposed to have been in Blackboard as a program that would monitor students taking tests, as I was looking into that software, it said that it would flag people if they weren't staring at the screen. And this is a math class. I don't want you staring at the screen. I want you doing the work on the side. So that does no good. And so unless your time outside of class is not accommodating, I was thinking that rather than giving tests during class time, they would be timed. You have to take them during a certain period of time. But if you take them outside of class time, what that would do is it would free up another hour of class for us to do things like review, go over homework and things like that. Would it be problematic for anybody if instead of giving tests during class time, we gave them outside of class time, like a homework assignment, and gave you, it would be timed, but you could pick your own time of the day. Would that be all right with everybody?
Yeah, I think it would be better.
I was kind of wondering how like the tests were going to work with the Zoom setup anyway. So yeah, that's fine with me.
Yeah, I'd be okay with that.
The other thing that in terms of with the test, if it was during a Zoom class time, I don't know about you, but I am not the world's most technologically savvy person. And so I would think that it might be a little bit of juggling between the Zoom and the My Labs and everything. So right now, I think I looked up this morning and your first exam is scheduled for Monday, which is the 21st. And so I'm thinking of, and I will come up with a more like a 12-hour time frame in which for you to take it. But it would probably be sometime, before class time on Wednesday that you would need to have it finished.
I've got a question about our quizzes.
Yes.
Are they always going to be like either like one or the other on Blackboard or on My Lab or whatever?
I think I just made the executive decision that they're going to just
Just
be
be
in
on
my
Blackboard?
labs
Oh, my labs. Okay.
because I did not have anybody complain about technical difficulties when the quiz was in my labs. I did get a lot of complaints with people having problems when the quiz was in Blackboard.
So the one in Blackboard right now, that's due today.
Mhm.
Should we still take it on Blackboard, or is it going to be put up in my lab?
You know what? If you hadn't taken it already, it was actually supposed to have been completed by last night.
Oh,
Uh,
it says the 16th tonight.
That's the homework.
It says, I swear it says quiz.
Yeah, what had happened was one of the people who had technical problems needed to retake it. Peter, if you haven't taken it yet, stay on at the end of class and I'll talk to you about that. All right?
Gotcha.
Okay. So if those changes, I know I always feel terribly guilty when I've got something spelled out clearly in the syllabus and I change it. But this semester is a little bit different for everybody. Is everybody okay if I make those changes?
Yes.
Yes?
Mhm.
Yeah.
Yes.
If it's
Yes.
if it's problematic for somebody and you don't have time, talk to me personally, either come to my office hour or send me an email and we'll come up with something else. But right now, quizzes will be in my labs, tests will be in my labs, and tests will be outside of class time, just so that we get that extra hour of class time for review. All right?
Okay.
And then let me go back to sharing my screen. And this, the notebook for today. Homework 3 is due by the end of the day today. Homework 4 will be due by the end of the day on Friday. And homework 5 will be due by the end of the day on Monday. That test, again, it will be outside of class time. We'll discuss on Friday the different possibilities for time windows for that. Before we get started with today's notes, does anybody have anything that they want to look at from any of the homework problems? Does anybody have any questions that they'd like to go over? Should I open the homework up or not?
I have a quick question with the homework. There was a question, I can't really remember. It was like in the parentheses and then it had like A was what was it? Like the upside down U and
Uh-huh.
then B, and then another parentheses and then the little dash. I didn't really understand that very well.
Okay, all right. What you're describing to me is you're looking at something that was like this.
Yes, that one and then the other one just like that, but with the compare one.
The union.
The union, yes. Union and then compare, yeah.
Okay, over here, the A intersect B. Are you all right that that's what's common to A and B?
Yes, common. That's what I meant. Yep.
And so if I were to look at a Venn diagram with two sets, the intersection would be here. Yes?
Okay. Yes.
Now, when we put that apostrophe outside, that prime outside, it means that we want to take the complement, which is the opposite, sort of. It's the what's outside the set. So the complement would be everything else in the Venn diagram that's not in the intersection. Everything else
Oh,
in the universe that's not in the intersection.
okay.
In the same way, if instead it was A union B complement, A union B would be everything in the two sets put together. It's the whole sideways snowman. And when I take the complement, again, I take what's outside. So the complement of A union B would be this, like what I just colored in yellow.
Okay.
Is my horrible drawings enough to clarify it for you?
Yes, that makes sense.
And I'm gonna be that person again. I'm gonna say it over and over and over again. If you're working on the homework and you're doing a problem and it's not working for you, you think you're doing it right and you're not getting it right, please do not stress. Do not lose sleep. Do not get upset. Don't wait to class time to ask. But and now of course this is going to take forever to come in. Over here, the question help. Ask my instructor. And I can do that every time, damn it. But because I'm the instructor, it doesn't let me do that. If you use that ask my instructor, it sends me an email right away. And so I can get back to you before class time. And it also sends me the question you were working on. If you don't want to do that and you have a question on a specific question on the homework, just write the question number down and I'll make sure that we go over it at the beginning of class. Okay?
Okay, thank you.
Okay. Does anybody else want to look at anything else from any of this homework? Or we had started looking, and I think this homework 4 deals with the Venn diagrams with 3 loops. Go ahead.
Can you repeat what you were saying on the notes about the union?
When I look at the union of 2 sets, the right side up U, it's everything from both sets. It's combining the 2 sets together. It's all of the elements from both. And listening to these questions before we go on and look at the new flavor of the day, the idea of proving things, let's do a real quick question. I'm pulling one up from the actual textbook, kind of going over the type of things you folks are asking about. Let's say my universal set is numbers 1 through 5. I'm sorry, I said 1 through 5 and it's 1 through 7. A is the set 1, 3, 5, 7. B is the set 1, 2, 3. C is the set 2, 3, 4, 5, 6. Let's find a few things. And I'm writing too big. You know what? I think I can squish that down to make it a bit better. There we go. Let's find A union B intersect C. Let's find A union B complement intersect C. Are those 2 involved enough to kind of cover everything that we've been discussing? You know, questions you might have. With this first one, we do what's inside the parentheses first. So B union C is taking B and combining it with C. So when I take B union C, it's all of B plus all of C. 2 and 3 are in there already. I'll add 4, 5, 6. So do you see when I'm taking the union of the 2 sets, I'm just putting them all together. Next, I want to intersect that with A. Well, A is 1, 3, 5, 7. And what the hell did I just do? I read those symbols upside down. Let's try that one again. This is B intersect C, and so this is what do B and C have in common. What they share is 2 and 3. And then when we take A union that, we're taking all of A and combining it with that other set, which would give me 1, 3, 5, 7. You have to add the 2 and the 3 is in there already. I did get an email from somebody last night saying, what did I do wrong? It's not accepting this. And if you look in the fine print, after the blank that you type the answers in my math lab, the question that that student was doing said, put them in order. And so I know that technically you don't have to put them in order, but if the directions tell you to put them in order, you have to put them in order. So I think you got it right, but read the fine print. It says put them in order. So if it says, I think the phraseology at the end of the question was put your answer in ascending order. Ascending order just means write the numbers from smallest to largest. And so if you had the same things in your set as they did when you checked your answer, and you felt like you were banging your head against the wall, read the fine print underneath. If it says put them in order, you have to. That one, okay. This next one asks for A union B. So A union B, let's do that first. When I combine A with B, I get 1, 2, 3 from B. And then from A, I've got 1 and 3 in there already. I'll add 5 and 7. That's A union B. But this tells me the complement. So when I take the complement of that, I'm going to go up to my universal set. The union has in it 1, 2, 3, 5, 7. When I cross those out, when I take them out of my universal set, I'm left with 4 and 6. So the complement is not what's in that union, but rather what's outside of that union. Now, we're going to take that, intersect C. C is 2, 3, 4, 5, 6. And when I take the intersection, kind of like playing matchy-matchy. They both have 4. They both have 6. So that intersect would be, section, pardon me, would be the set 4, 6. And so as you're looking at questions like this with the roster, I'm going to tell you, I cannot look at that and say, oh, I know the answer. I have to write down on paper the in-between steps, which is why, again, I give credit for showing your work. I know I was talking to somebody before class, and they said that looking at the roster just confused them, and they found it much easier if they were given a Venn diagram. And so if you're given a roster and you're not seeing it from the roster, and you see it more clearly with the Venn diagram, gosh, draw the Venn diagram. Venn diagram for this, they all have 3. A and B also share 1. B and C also share 2. A and C also share 5. A also includes 7. All of B is in there already. C has 2, 3, 5. It also has 4 and 6. And our universal set has 1, 2, 3, 4, 5, 6, 7. So everything's in my universe. And if it's easier for you to get that by looking, over here this says what's outside of A and B. I'm looking at this last one that's boxed off. So A union B is what's in the snowman. The complement is what's outside of the snowman. And where the outside of the snowman intersects B is the 4 and 6. As opposed to if I were trying to get this one from the diagram, B intersect C is this part here, the 2 and 3 where they overlap. And so when I union it with A, I add what's in A, which gives me the 1, 2, 3, 5, 7. So if it's easier for you to see from a diagram, draw it. If it's easier for you to see from a roster, write them out. And again, especially if there are parentheses in there, or if there, it's a multi-step problem. Find what's in the parentheses first, and then treat that as a single step and go on. Does that help anybody?
Yes.
So if that's all right, there's plenty of practice on those with 3 sets in the homework that's due Friday. What's also in that homework that's due Friday is the idea of proving a set theorem. If I were looking at a specific problem, a specific Venn diagram, a specific group of sets, I could write an equation and say, hey, let me do it out and see if the 2 sides are equal. But sometimes instead of,
Excuse me.
for example, we want to show that a relationship is always true. And so we use Venn diagrams in which to do this. And so what we're going to do is we're going to draw and label, and that's that Roman numeral labeling. But if you don't like Roman numerals, you can use regular numbers if you're doing it on scrap paper for yourself. The regions of a general Venn diagram. Then we're going to make a table to determine what regions are included in the left-hand side of the equation. Then we're going to make a table to determine the regions. In the right-hand side of the equation. And then what we're going to do is we're going to compare the two. And what happens if the two are the same? It's true. And if the two are different, it's false. And let me apologize in advance. Yesterday, after my last class, I went to help my daughter walk her dog, and I was holding the leash. And he's a big dog, and he's just a puppy. He's only like 7 years old. And he suddenly turned direction and pulled me down, and I fell, and I landed on my hands. And so my hands hurt like hell. So during the course of the day, I think my penmanship's going to get really crappy. So I'm apologizing in advance if my penmanship deteriorates. If you can't read it, tell me that I got to go a little bit clearer.
Are you okay?
Oh, yeah, just brush burns. But, you know, as you get older, when you bang on the blacktop, you get a little bit sore than when you used to fall like that as a kid.
Yeah,
Glad you're
I'm
okay.
Yeah, he's the puppy. He's beautiful. He's half collie, half Bernese mountain dog.
Ooh.
So he looks like a collie, but he's the size of a mountain dog. And so he's only 7 months old, but he probably weighs between 70 and 80 pounds already. And
Nice.
so he can pull harder than me times. I'll have to show you folks a picture of him at the end of class. I'll pull one up on my phone. Does everybody have the words written down? Because I'm guessing at this stage of the game, it is sort of just writing words down. And I think it's probably about as clear as mud right now. So I think an example will clear this up a lot. Is everybody out ready for the example, or are you still writing the directions?
I'm ready for the example.
Okay. So for the example, I want to know, does A intersect B complement always equal A complement intersect B complement? Well, how are we going to do that if we don't have a set? We don't want to show it for specific sets. We want to show it for a general Venn diagram. So let's start by drawing a Venn diagram. Look at what we're given. I need you guys to help me out here. Would you make a 2-looper or a 3-looper?
2.
2.
Because we only have A and B. You remember 2 loops, we have 4 regions, so we'll number them 1, 2, 3, 4. So far, so good. General Venn diagram. And again, if you're doing this on your own, you can use regular numerals if you don't like Roman numerals. However, in my math lab, they are going to use Roman numerals. Now we're going to make this big table. On one side, we want to know what regions would be in A intersect B complement. On the other side, we want to know what regions are in A complement intersect B complement. When I do this, I make a list of the set that I'm looking for in the region. Now, how much work you put into this table is a matter of personal preference. But when all is said and done, bare minimum, what I need to see from you is what regions are in A intersect B complement, and on the other side, what regions are in A complement intersect B complement. There are some people who just cut to the chase and do that and get that from their diagram, and that's perfectly fine. However, if you don't have a lot of confidence, if you break it down into baby steps and show each part, you're more likely to get partial credit. So as I go through this example, I'm going to show as if I wanted to show absolutely every thought that went into my head. Looking at this one, you have to start inside the parentheses. So we need to know what's in A intersect B. In order to do that, I could say, okay, what's in A? Regions 1 and 2. What's in B? Is everybody all right? B is regions 2 and 3. And so I need to find A intersect B. And what do those two have in common? Region 2. But I don't want the intersection, but rather its complement. And so if I look at my Venn diagram, if I exclude the intersection 2, I'm left with 1, 3, and 4. Done bare minimum, I need to see this bottom box. But if you want partial credit for showing your work, does it make sense? The more steps you show me, the more I can give you partial credit. On the other side, I guess technically if we wanted to show every single step, we'd need to show A and B again, but I've got them written. So on the other side, because I already know A, I'm going to say what's A complement. Well, if A regions 1 and 2, A complement, everything else would be 3 and 4. Likewise, if B is 2 and 3, B complement would be 1 and 4. And now when I take the intersection of those two, what do they have in common?
4.
4. And so do you see what I mean? Decide what regions are included. And again, show the steps, gives you more partial credit. If you don't have the patience for that and could have looked right at the Venn diagram and gotten these, as long as they're right, I just need to see what those regions are. Is everybody all right with that part of the directions that say draw a Venn diagram, see what regions would be in the left, see what regions would be in the right?
Wait, so is this true or false then?
You know what? Thank you very much. You're pushing me along. I wanted to make sure everybody was right to hear. But now let's answer that question. Are those two the same?
No.
Is this
No.
the same as this? So no, it's not true. If it were true, I would say, yeah, you know, if they were the same, I would say, yes, it is true. But they're different, so it's not. And so do you see, rather than working with elements, we're working with the regions of the Venn diagram. And then by doing that, we're showing it's not true for a specific example, but it would be true for every example. It leads to things, if you're really interested in this stuff, there are different laws that hold for sets. So one is De Morgan's law. And so laws would be proven like this. Should we do one more? Well, I'm going to do one more, and I want to do a big one. I want to know, does A intersect B union C equal A intersect B union A intersects C. All right, what's different with this one?
It's going to have 3 loops.
It's going to have 3 loops, and because it's going to have 3 loops, rather than just worrying about 4 regions, we're going to worry about 8 regions. Make sure you label your sets. And the regions go 1, 2, 3, 4, 5, 6, 7, 8. We've got to figure out what would be an A intersect B union C. And then we have to figure out what's an A intersect B, what's an A intersect C, and take their union. And then decide if the two are the same. On the left, is everybody all right that I'd probably start with what's inside the parentheses? So B has regions, I apologize, I forgot to label that these are the sets, these are the regions. What regions are inside set B? 2, 3, 5, and 6. What regions are in set C?
Uh, 4, 5, 6, and 7.
So now I can sort of just look at my list and take the union of those two. When I put those together, I would get 2, 3.
You put BUB.
What?
Said you
Oh,
put
thank you.
BUB. Mhm.
Thank you. 2, 3, 4, 5, 6, 7. And again, if somebody could have just looked at the Venn diagram and gotten that list 2, 3, 4, 5, 6, 7 by inspection, that's fine. Now A is 1, 2, 4, 5. So when I take A intersect B union C, what does A have in common with the union of B and C? They both have
2,
2
4,
and 5.
4.
4 and 5. So far, so good.
Yeah.
Now, on the other side, there's no need to reinvent the wheel. We've already got A. We've already got B. So I can jump to A intersect B. And what does A have in common with B? I can get it by looking at my table here, or I can get it by looking at my Venn diagram. Does everybody see A intersect B would be 2 and 5?
A intersect B.
A and B both have 2 and 5.
Okay.
Then we need A intersect C, the other parentheses. What does A have in common with C?
2, 4, 5.
I'm just looking. As I'm looking at,
4.
I don't see 2.
4, 5, 6, 7.
C has 4, 5, 6, 7. A has 1, 2, 4, 5. So can we say that they share 4 and
4,
5?
5.
We want, what does A share with C when we take that?
Oh, yeah.
And now last step, we'll take A intersect B and union it, combine it with A intersect C. So when I combine those two, if I just put them together, wouldn't I have 2, 4, 5?
And it's a true because
And this one's true because they're the same. A, that, wow, what happened there? My exclamation point went in the middle of my letter E. A intersect B union C is the same as A intersect B union A intersect C. If anybody's interested, what we really just proved is that intersection distributes over union. It's like a version of the distributive property that holds true for sets. I'm not going to ask you to remember the name of theorems, but I'm going to ask you to understand this process of using regions to show whether something is true or not. What do you folks think?
Okay.
All right.
I'm good. Yeah.
Now, there's one last topic that we have to cover. And it's using Venn diagrams to organize survey results. I'll leave it up to you folks. Tentatively, that test is going to be after class, time Monday. Should we wait till Friday to bring up this new topic so we're not like jumbling up things too much? The the survey results is what's in that homework 5 that isn't due until Monday. Did you want to stop here? Did you want to do another example? Did you want to do
Can we do another example?
Sure. Want to do a 2-looper or a 3-looper?
Both.
3.
3.
Okay, let's see. Does A complement intersect B union C equal A complement intersect B union C? And not gonna lie, I just made that up, so I have no idea whether that's true or not.
Okay.
Okay. You said you wanted to do another one, and I'll tell you what, this time I am gonna shut up. I'm gonna stop sharing my screen as soon as everybody has that written down. I'll work it out. I'll ask you guys to work it out. And then we'll give everybody about, these are a little bit more involved. Should we give everybody about 5 minutes and then we'll go over? Sound like a plan?
would be 3.
Are we ready to look back at it again, or do you folks want me to wait a minute?
Another minute?
We can even wait too if you want. So let me look at the list of names that are here and see if there's anybody who showed up that I didn't get on attention's first time through. Kaylee? Aaliyah? Jamaica?
Kylie's here.
What?
Kaylee, it's pronounced Kylie, and is here.
Oh, I'm sorry, Kylie. Thank you.
Oh, yeah, I'm here.
Kylie, you're here. And who else is here?
Maddie's here.
Maddie, Joel? Okay, Maddie, I got you before. Somebody.
Okay.
Omaru? You here?
Yeah, yeah, yeah.
All right, thanks. Are we ready to go over?
I guess.
I got that it was not true.
So did I.
Yeah.
For A complement intersect B, I got 3 and 4. So when I'm sorry, 3 and 6. So when I unioned that with C, I got 3, 4, 5, 6, 7. For A complement intersect B union C, I just got 3, 6, and 7.
Woohoo!
So it's not true. Was that, well, a good thing or a bad thing?
It was a good thing.
Good. You made
I
my
feel
day.
smart for a second.
You made my day. That enthusiasm towards math is something I wish I saw more often. Okay. If these are all right, then I'm going to be a jerk for a minute. And I'm going to, let's see, stop sharing. And I'm going to show you that Moosey. Can you see him?
Aw.
That's me on the couch behind him, so you can see a little bit of the size differential.
He's sweet.
He's beautiful, but he's
Big
that
puppy.
big. And he's only 7 months old. So picture a 7-month-old puppy bounding around the house when they take up half the living room with each stride.
Yeah.
All right.
You got a big but young dog here too, so.
Okay, what type
I
of
feel
dog
ya.
do you have?
I think he's a mixed breed. I don't remember what though.
Okay. All right, well, I'm going to stop recording.